Okay, so we're going to talk about some basic differentiation rules. Alright, so you've got if c is a real number, n is a rational number, and f of x and g of x are both differentiable functions, then each of these following rules is true. Alright, so you've got the constant rule. Remember, a constant is just something that doesn't have a variable attached to it. So if I take the derivative of a constant, it's just 0. Then you have the power rule that says, well, if I have a number raised to a power, I can pull that power to the front, just like I did here, and then decrease the power by 1. Alright, you will use that a lot. Alright, the constant multiple rule. If I have a number multiplied by my function, then I would take that number times the derivative of my function. Alright, the sum rule, if I have two things being added together, I'll take the derivative of both things and still add them together. Same thing with subtraction. And then the derivative of sine is cosine, and the derivative of cosine is negative sine. So number 1, I've got 2x squared plus 7. So remember, when you have a number being raised, or when you have something being raised to a number, a variable, you're going to take that number and pull it down to the front. So this 2 stays here, but then I'm going to multiply it by the derivative of this. So I'll take the 2, pull it down front, and then I'm going to decrease that power by 1. Then I've got the derivative of this number at the back. So the derivative of just a number is 0. So I'm going to finish this off. I've got 2 times 2 is 4, x to the first, I don't write the first, and then plus 0, so it's just 4x. So f prime of x is equal to 4x. And I just want to show you something. Don't write this down, but pay attention. We've been doing the derivative, but we've been doing it a long, drawn-out way, where we take and we plug in x plus h. Then we subtract the whole function. And then we divide it by h. So let's say I do this. This would be x squared plus 2xh plus h squared. So I've got 2x squared plus 4xh plus 2h squared plus 7. Distribute the negative, so I get negative 2x squared minus 7 all over h. So 2x squared, negative 2x squared, 7, negative 7, h, h, h. So I get 4x plus 2h. I plug in a 0 right there, which is going to cancel this whole thing out, and I'm left with just 4x. That is way longer and more complicated than this is. So essentially all you're doing is pull this down and multiply if there's a number in front. So 2 times 2 is 4, decrease by 1, so you have 4x. This is just 0, you're done. And bada bing, bada boom. Alright, so I have something something minus something plus something. So we do all three of these separate. Okay? So you've got 3x squared. So I'm going to pull the 2 down. So I have 3 times 2 is 6. X to the 2 minus 1, which is just 1. And then this is just going to drop off the face of the planet because it's just going to be 0. And then the derivative cosine is negative sine. So this is gone, right? So you have 6x minus sine x. And that, oh, that is your derivative. So just to reiterate, 2 times 3 is 6, x, and then take 1 away from this power, so that would just be a 1. This will be 0, and the derivative of cosine is negative sine. Alright, so if I look at this one, number 3, I would pull the 3 to the front. There's just a 1 there, so that would be 3x to the decreased by 1. So this would be 2, and I'm done. All right, number 4. I'm going to do the same exact thing that I've been doing. So I'm going to pull the negative 4 down, and I'm going to subtract 1. So negative 4 minus 1 is negative 5. Now we do not leave exponents that are negative. So the way you change that to positive is this is in the numerator. So what we're going to do is we're going to move it to the denominator, which will then make that a positive 5 in the power, which you learned that in Algebra 1. So little quick thing there. So if I had something like this, I could move it up into the numerator and the power would become positive. Okay. All right. So you have 1, 2, 3 things being added together. So do each little derivative separately. 8 times 2 is 16. X to the decreased by 1, 7, plus 7 times 3 is 21. X decreased by 1 to the 6, minus 9 times 6 is 54. X to the decreased by 1 fifth. I mean, can you imagine having to do that using the x plus h? I don't think you even want to try that. All right, number 6. So I've got 4 thirds times 2 is 8 thirds. X to the subtract 1, which, remember, that would just be 3 over 3. So 4 thirds minus 3 thirds would be 1 third. And then I'm not sitting at school at my desk, so I'm not sure how far I wanted you to go on this. I may be okay with that, but if you'll recall, this is like this is a root, a cube root, because that number is in the bottom there. So you could actually take this a step further and say that, since this is in the numerator here, you could say 8, and this would be the cubed root of x all over 3. I would probably actually prefer that. Throw them back to our Algebra 2 days. All right, number 7. Sorry, my pen is fritzing. Okay, so you've got a negative 8 sine x. Well, the derivative of sine is cosine, so this would be negative 8 cosine x. And the derivative of cosine is negative sine, and you're done. All right, so this is kind of a new one right here. We just talked about this in power form. So this would be 1 over x to the, this is a first power here, so 1/8. But we can't do a derivative until everything is in the numerator. So we're going to move it up to the top, which means that our power is now going to become a negative 1/8. So now I have f prime of x is equal to, pull the negative 1/8 down, but, don't draw those, oh no, don't draw those terrible lines there. Okay, so pull the negative 1/8 down, then you've got x decreased by 1, so you'd be subtracting 8 over 8, so that would give you negative 9/8. So now I'm going to move that part to the denominator because this x to the negative 9/8 is on top, okay? So now I've got negative 1 over, this is the 8th root of x to the 9th power. And because I moved it to the denominator and made it into this root, that made this power a positive. Fabulous. Okay, last page here. So we're going to make this into a fractional exponent. So this is a 1/3 power, so this will be x to the 1/3. And then there's nothing wrong with 5x to the 9th. But I will tell you this. I don't ever take the derivative of anything until everything is in the format that I want it. Otherwise, I think, okay, I'm going to take the derivative, or I'll, write this one. I'll take the derivative of this one. But then I forget that I took the derivative of that one, and then I do it twice. So write everything like you want it before you take the derivative. Okay? So this would be, pull the 1/3 down, decrease by 1. So 1/3 minus 3/3 is negative 2/3. All right, then you've got 9 times 5 is 45. X to the decrease by 1/8. So over here, I have a negative exponent in my numerator. So I'm going to put that on the bottom with the 3. So this would be a cube root of x to the 2nd power. And then there's nothing wrong with my 45x to the 8th. All is well there. Okay, 2 more of these. All right, so like I said, don't take the derivative until you have written everything like you want it. So we don't want anything at all in the denominator. So I'm going to move everything to the top. So this is a 1/5, right, power. So I'm going to move it to the top and make it a negative 1/5 power. Same thing here, but this actually doesn't have the root, so it would just be a negative 4 power. So I've got negative x to the negative 4. Now I'm ready to do the derivative. So I take the first derivative. 3 times 7 is 21. X to the 2nd. I'm going to pull the negative 1/5 down, so that's going to give me a positive 4/5 x to the decrease by 1, which would be 5/5. So I get negative 6/5. Then I've got negative 4 times negative 1 is positive 4 x to the negative 5th. You got to be really careful because sometimes, when you subtract one, you want to think that it's supposed to be like a negative 3, but it's really, negative 5. So now I've taken my derivative, but I got to take care of these negative exponents and fractional exponents and all that jazz. So 21x squared is good to go. I don't have anything wrong with it. However, I have a negative power here, so I'm going to put it on the bottom with the 5. And this is a 5th root of x to the 6th. All right, plus 4 over x to the, my lordy, x to the 5th. Okay, last one. So I'm going to make this into an exponent. So that would be a 1/3 power. Alright, there's nothing I need to change on the 2x to the 4th. But I do need to pull this x to the 6th up to the top. So that would be x to the negative 6th. And then I'm ready to do the derivative. So I'm going to pull the 1/3 to the front and decrease. So 1/3 minus 3/3 is going to give you negative 2/3. 4 times 2 is 8. Decrease by 1. And negative 6 times 1 is negative 6. X to the decrease by 1, negative 7. Now I just got to take care of all the fraction exponents and the negative exponents. So this will move to the bottom with the 3. So I have 3, and then the cubed root, because the 3 is on the bottom here, of x to the 2nd. Then you've got 8 times 3. Oh, look at me trying to take the derivative. Just 8x to the 3rd. We've already taken the derivative. Alright, and then I've got negative 6 over, this would be x to the positive 7. And you are done.